Good morning, class 10th. Today we will start first exercise of real numbers. Exercise 1.1. Question number 1. Saying use Euclid division algorithm to find the SCF. Find SCF. A part given 135, 225. 135 and 225. Using Euclid division lemma, since 225 is greater than 135, therefore 225 is equal to 135 into, you have to find here 225 135. So 270, 2 times it will cross, so we will take 1 time. 135, 5 minus 5, 0, 12 minus 3, 9, 0, 90. Now this 135 will come here, 90 is a 90 again, 45. Again this 90 will come here, 45 2 is a 90, remainder 0. So this we can write 135 into 1 plus 90. Again 135 is greater than 90. So 135 is equal to 90 into 1 plus 45. Now again 90 is greater than 45, so 90 is equal to 45 into 2 plus 0, 45 2 is 90 plus 0. Since r equal to 0, therefore 45 is your SCF, is equal to 45. Clear? Similarly you will do second part. I am going to do question number 2. Question number 2, saying show that any positive odd integer is of the form of 6q plus 1, 6q plus 3, 6q plus 5, where q is some integer. Let a be a positive integer and b equal to 6. Therefore r is greater or equal to 0, less than 6. So r is equal to 0, 1, 2, 3, 4, 5, less than 6. So less than 6 till 5. Now integers 6 b 6, so 6q plus 0, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4, 6q plus 5. Now 6q plus 0. When 6q plus 0. So this we can write 6q. This implies to 2 into 3q, or you can write 2. We have done na 2m 2k form, so 2k1. There k1 is positive integer. When 6q plus 1. So this is 6q plus 1, we can write 2 into 3q plus 1. 2 3 is 6, 6q plus 1. We can split it. Now it is the form of 2k1 plus 1. Here k1 is equal to 3q. We can write here where k1 equal to 3q. Next, formation 6q plus 2. So 6q plus 2, we can write 2 into 3q plus 2. Now see, here 2 is common, so we can take 2 common. Inside will be 3q plus 1. Clear? It is written 2 3 is 6q, 6q plus 2. Now 2 here common, so take 2 common outside, so inside will be 3q plus 1. Now this is in the form of 2 into m. Again we can write 2, take it k2, here k3, 2k3, where k3 is equal to 3q plus 1. Now similarly we will do 6q plus 3. So it will be 2 into 3q plus 2 plus 1. 2 3 is 6q, plus 2 plus 1, 3. Now again 2 common, so we will take 2 common outside. So inside will be 3q plus 1. This was 3. So 3q plus 1 plus 1. From this 3 we can take 2 common, so outside will be plus 1. You can check 2 3 is 6q, or this 2, 6q plus 2 or plus 1, 3, 6q plus 3 form. Yeah? So we can take 2 common and outside we can write plus 1. Again we can convert this 3q plus 1, so it will form 2k4 plus 1 form. Again k4 equal to 3q plus 1. When 6q plus 4, so you can write 2 into 3q plus 2 into 2. Again 2 common, inside will be 3q plus 2. You can check 2 3 is 6q or plus 4. Again you can write 2k5 plus 1. k5 is equal to 3q plus 2. At last, when 6q plus 5, so you can write 2 into 3q plus 5. 4 plus 1 you can write. So again take 2 common till here, so inside will be 3q plus 2, outside 1. 2 3 is 6q plus 4 plus 1, 5. Again it is form of 2k6 plus 1, where k6 equal to 3q plus 2. So this way you can see, he was saying for odd numbers, show that any positive odd integer. Odd integers are this one 2k plus 1 form, 2k plus 1 form, this one, and 2k plus 1 form. It was a 4, sorry, this one is only k5 because 3q plus 2 is k5, so 2k. Last one is 2k6 plus 1, this one. So we can write odd integer in the form of 6q plus 1, 6q plus 3, 6q plus 5. So right answer, what is saying, show that. So we have shown any positive odd integer, therefore any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer. True. Clear? Thank you, class.